Great. So welcome, and look forward to the next session by Ted Way to chat with you folks about generating the future AI and foundational models in the enterprise. So just as a reminder, we're here to learn, but also get some input later on in terms of things you folks would like to see. So let me just turn it over to Ted.
Okay, great. Thanks so much, Paul. All right. So hello again, everybody. And I know some of you were in the session on Monday. So the first half of it will be a bit of a repeat from that. So if you were here on Monday, just laugh at the right places and say, cheer at the right places. So if you could just do that for me, that would be wonderful. And as Paul mentioned, I'm Ted, and so I work as a product manager on our business AI team. And so in sense of a little bit about my background, and this is actually related to what Mangesh presented. I did my PhD in what we call spell check for radiologists, where you're looking at a CAT scan or a CT scan, and then basically using AI to try to figure out whether abnormal tissue is cancerous or not, and what is the malignancy rating. And you're probably familiar with X-rays, right? X-rays is essentially what you're doing is you're taking a picture, and then you're just getting an image, and then that's it. It's just like a 2D image. CT, or computed tomography, is you're taking a picture from this angle, 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 and you're taking all of those signals and putting together one image. That's how you get that three-dimensional image. And so that was a long-winded way of saying you'll see some of the similar stuff that Mangesh had just talked about, and the next speaker will talk about. But hopefully it's in a few different angles so that you'll be able to piece it together and then kind of have an understanding of this. So today, what I'll talk about, again, the first part is really just the data science behind generative AI models. Because as enterprise architects, a lot of words I hear are boxes and patterns. And I think you just want to put, LLMs into a box. Okay, so what is that box? What goes on in that box? And so I'll try to give a little bit of a, peeling back the covers and looking underneath the box to just get an idea of, okay, what are these LLMs? What do they actually do? Then you can kind of have an idea of what they can do and what they cannot do. Right? You were probably all part of the data lake craze where, hey, we just have a data lake, and if you put all of your data in the data lake, you'll get rainbows and unicorns out the other side, right? But that's not necessarily the case. Same thing with LLMs. There's some things that they're really, really good at, but then there are some things that they can't really do. So I think having an understanding of the data science behind it will probably help you be better equipped in understanding what can be solved and what cannot be solved. And then we'll talk a little bit about the patterns of what are the capabilities. As I was thinking about how I wanted to frame this talk, a laundry list of SAP features will probably make you even more sleepy. So let's instead take a step back and talk about what are these patterns. And the main patterns, if you think about every single use case and every single customer problem, they all can map pretty closely to some of these, right? The first one is just answer generation. You have a question. You have data. The data is structured. The data can be unstructured. How can you ask a natural language question and get an answer from your data? That's basically the first pattern, answer generation. The second one is content generation. You want to generate some content. Give it a little bit of a prompt. I want to create a job description. I want to create a marketing campaign email. I want to do XYZ. Generate me something that will be along the lines of a prompt. So generating content based on the data that you may have. And the third one is action generation, meaning that you can take action based on natural language. So this is the commanding part of things. For example, one of the things that I was working at Microsoft was automated flow and process generation, in the sense that every time I get an email with an invoice attached to it, save it to this OneDrive folder, and then kick off this approval process. I can literally say that in English and then be able to write the code underneath the covers. The AI model will write the code to be able to do that process automation. And so the idea is you may be in the Joule interface and you may not be very familiar with this SAP app, and you'll be able to say, oh, where do I go to do XYZ? And it will take you there, for example. Or I want to execute this, and they'll do that underneath the covers for you, right? That's action generation. And then finally, I'll just spend a few minutes on our AI roadmap. But as you probably know already, that's on our roadmap website, and you can see an idea of where things are going from a product engineering perspective. All right, so I think you've seen this enough times, and you've also seen this enough times in terms of relevancy, reliability, responsibility. I think we haven't talked about AI ethics as much, but again, that is foundational to everything we do when it comes to AI. And so in the ways in which we do things, one is we have an AI ethics board. So every time there is going to be a launch of a feature that will be using a large language model that's embedded in an SAP product, that will undergo an AI ethics review. There's going to be things like red teaming and just making sure that the responses that we're getting from the LLMs are going to be aligned to what you're expecting, right? So we take this super, super seriously because we want to make sure that, one, it solves your problems, and two, the LLMs don't go crazy and start telling you they love you or something like that. So AI ethics is critically important. All right, so let's go a little bit into the data science behind generative AI. First, just to level set on the things that you've already probably know and love, right? So you can go to a ChatGPT today and say something like, write a haiku about enterprise architects and embracing change, right? You go there, ChatGPT will say, blueprints transform, architects mold shifting tides, changes embrace, bold, right? Like, this is something that ChatGPT can just come up with in just a few seconds. And if you think about it, it is actually pretty insightful and pretty deep, right? And it is amazing that these models can do this. Or you can even ask it to generate code. Write a Python function that generates Fibonacci numbers. And here's that Python function. It will actually give you the actual way that you can call the function, right? This is things that it can do from a text and a code perspective. You can also ask it to generate images, right? Generate a photograph of a big pile of laptops, Xbox game consoles, and iPhones outside SAP's North America headquarters. And I was joking with Paul on Monday, hey, wouldn't it be great if this was just outside for us right now? And these are the attendee gifts for the Enterprise Architect Forum. But basically, it can generate images. And it can, Sora, that was just released by OpenAI, can generate video, right? So here is a video. The prompt is a gorgeously rendered papercraft world of a coral reef rife with colorful fish and sea creatures, right? So this came out of a foundation model. Based on just a few words of English, this is the high-quality video that is possible today. So how are all of these things done, right? So as we look back, as we look into the models, the first part is let's just get a level set on what data science is. Data science, machine learning is essentially building predictions. You can think of it as building predictions based on the data. So I recently joined SAP in December, and I'm very interested in seeing where the stock is going. And what I want to do is build a prediction model for predicting the stock price of SAP in the future. And none of this should be new to you, right? You've probably done this in Excel. I've downloaded the closing price of SAP stock since September of last year, and I just plotted it in Excel. Nothing different from anything that you've done before. And then what I did was I added a trend line. Again, you've probably done this, right? This essentially is quote-unquote training a model. So anytime a data scientist comes to you and says, hey, please pay me 5 times more than what you're making because I train models all day, it's kind of what they're doing, right? But it's just taking data, picking a model, and then training that model based on this data. And this model, in essence, is a straight line, and it has 2 parameters. The parameters are M and B, right? And this is what the model is basically doing is saying, OK, I have some data. I'm going to fit to that data, and then I'm going to predict based on this model. A model is just a simplified representation of this complex world. The complex world is, that blue line, and I'm trying to simplify my representation of it so that I can understand it and make predictions off of it. So a machine learning model is no more than that. But how I got here was I made a decision. My decision was my model is going to be a straight line, and I only have 2 parameters, right? That's a restriction of the model, but basically that's the choice that I made. And if I plug in a value for x, such as for Monday or even for tomorrow, I will get a prediction for SAP stock price. And I put in the date X, and then it comes out with some prediction, $180. And if you actually check, I think it's like 187 or something like that. So something good happened end of last week. I don't know what, but my model did not capture it. So you know that this is not a very good model, right? Anytime you want to try to get rich on a model like this, it's not going to happen. And that also shows you the limitations of machine learning. If you did not capture the underlying forces or the underlying features of all of that data, then your model may not give you the right prediction. But this is just basically machine learning in a nutshell. You have data, there's some model, you're fitting it to the data, and then you're able to make predictions based on this model. And in this case, this model is a very, very simple equation, y equals mx plus b. And this will be important as we talk about what LLMs are. All right, so with SAP stock price, I downloaded some information, and then I fit a line to it. But how are LLMs models trained? How are these foundation models trained? The way I like to think about that is you're essentially playing a fill-in-the-blanks game with the internet, right? So all the LLMs that you know and love, GPT, Claude, Llama, they do the same thing, playing a fill-in-the-blanks game with the internet. So you take some text from the internet, and you know the answer already. But you blank out some words, and in this case, here's a sentence. The firefighter sprayed blank on the blank. OK, so the training process with this model is I'll say, Claude, GPT, Llama, fill in the blanks. And GPT will say, OK, my guess is the firefighter sprayed gas on the fire. And we'll say, no, that's wrong. That's not the way it is. The answer is the firefighter sprayed water on the fire, right? And then GPT will update its parameters, right? In this case, we talked about the previous model only having 2 parameters. GPT-3 has 175 billion parameters. GPT-4 about 1 trillion parameters. It will update its parameters and say, oh, OK, what do I need to update so that it's the firefighter sprayed water on the fire? And then it updates. And then you take another sentence or paragraph from the internet, blank out some words, and you play the game again, and again, and again, and again. And when you've played that game with this LLM, with every single sentence and paragraph from the internet, you get a pretty good model. And that's what's really happening. These models are trained on the text of the internet by playing fill in the blanks, and that's why they're able to generate text that sounds really like what a human would write. And that's what's happening as these models are trained. And that's why these models take months and months to train, megawatts of energy, and that's why they're humongous, and that's why they take a long time to run, right? Because fundamentally, that's what's happening. Now, how are the predictions generated? So Mangesh talked about prompts. A prompt is just an English or another language sentence that goes into the model. So in this case, I will prompt a large language model and say, write a riddle about enterprise architects. This goes into the model, and then the model will predict what word should come next. And based on what that model is trained on, it will predict this word. And it predicts the word why. OK, great. Then I do it again. The input to the model now is the original prompt plus that first word that was predicted. So write a riddle about enterprise architects, why. This goes into the model, and I'm asking it to predict that next word. And then it says, why did. That's the next word prediction. And then I do it again. The entire prompt, the 2 predicted words, all go as input into the model, and I ask it to predict the next word. And it says, why did the? Why did the enterprise? Why did the enterprise architect? Why did the enterprise architect cross? And all of you will probably guess as humans what the next few words are. But that's what's happening with the model. So if you think of what GPT means generative pre-trained. Generative comes from the idea that it's generating an output. The way it's generating the output is that it takes the input and predicts the next word. And it takes that input and predicts the next word. And it takes that entire input, predict the next word. That's the generative part. The pre-trained part is that this model was already pre-trained, right? We played our fill-in-the-blanks game with the internet, and it doesn't change. The model will not change, right? So if you ask the model, what riddle did you just write? It's not going to know because it didn't change. And so that's the pre-trained part. And then transformer is what we'll talk about next. But that's what's happening underneath the covers. All it's doing is predicting the next word in a sentence. What this means is, from an implications perspective, is that it has no concept of truth, right? When you go to a model, all it's doing is just statistics, and it's predicting the next word. And the way that it was trained was it learned it on the internet. There's a lot of good stuff on the internet. There's a lot of garbage on the internet. But whatever was on the internet, that's what it's using to predict what that next word is. And so that's why grounding is important, what we'll talk about in a little bit. That's why analyzing the output that comes out of the model and making sure and validating it. If you go to Bing search and you use Microsoft Copilot and you ask a question, it will give you a provenance link in the sense that you can click on where that data came from, right? These are all things that we need to do to ensure that the output of the model is what you expect, because it, again, has no concept of truth. It only will generate the next word based on what it thinks is the most likely. Now, these words are not necessarily the actual input to the model. The idea of attention, you probably have seen this paper, Attention is All You Need. This was the seminal paper that came out, I think, about 7 or 8 years ago now, from folks in Google Brain and others. And this was the idea that kicked off the whole transformer architecture. Probably heard of transformer architectures. That's the foundation of all of GPT and the large language models today. And the idea behind attention is that some words are related to others in a sequence. If you take a sentence, some words are related to others, and then there's probably a relationship between those words. And what it's trying to do is pick up those relationships. So for example, here is a sentence. Write a riddle about enterprise architects, why did thee? And if you run it through this attention mechanism, it'll probably be able to pick up that write has to do with riddle. There's a relationship between write and riddle, right? In the sense that, what am I writing? It's a riddle. What am I writing about? Enterprise architects, right? And so because of the pre-training, it's able to identify these types of things. And then I do that with every single word on the input. Riddle, what kind of riddle is it? About enterprise architects. How do I start the riddle? With the word why. What am I doing with the riddle? I'm writing it. So the idea here is there's some idea of the relationship between a specific word and the other words in a given sequence. This information is then transformed, right? You ever used Photoshop or your phone? You kind of blurred a picture, or you sharpened a picture, right? You're essentially transforming that picture. And these models are doing the same things. They're transforming these words. And the way that these models are transforming the words is that it's using the self-attention information, and then it's creating new words, if you will. So the actual input that's going into the model is not necessarily the English word right. It's going to be a made-up word. The made-up word could be, write, riddle, and arch, something like that, right? Or, riddle, why, and arch. This is a transformed word that goes into the model, except this is just one layer of that transformation. There's actually 96 layers in some of the earlier models. So you can imagine this sentence with these made-up words being transformed one more time after the attention mechanisms and some more transformations, and then you do it again and again and again, and 96 times later, it's probably going to be something that humans don't really process well, can't even understand what that means. But for whatever reason, the model with these transformed words is able to pick up things and generate the things that make a lot of sense. So this input to the model is filled with made-up words. The made-up words are a combination of the original words, and the made-up words kind of give the model an idea of the relationships, right? Here, the word right, it has to do with riddle, it has to do with enterprise architects. This is the made-up word that goes in there. And because this is the made-up word that goes into the model can then predict, OK, what word should come next? And the word to predict, it will give you a list of the most likely words. And again, the output of these will be made-up words, right? One made-up word is crossroad street. The other word is hit fist computer. Another word is draft arch diagram, right? These are the made-up words that come out. And then what finally happens is the made-up word gets mapped to a real English word. So this crossroad street basically means cross, right? Cross could mean a lot of different things, right? It could be, a Christian cross. It could be crossing the road as a verb. But in this case, this made-up word has to do with crossing a road or a street, and it maps to the English word cross. So what comes out of the model is the word cross. So all of that is happening underneath the covers. The input gets transformed multiple times to a place that the model is able to generate an output that has to do with this input. And that's why these models can generate outputs that look very much like what humans are able to write. And again, all of these patterns are picked up from the internet, right? Maybe the part of the training process, it found like this website of enterprise architecture jokes. Maybe that's what you guys go to all the time. And then when you have riddles about enterprise architects, it turns out that why did the enterprise architect cross the road? That just was a pattern that it picked up, right? And because of that, that's why the model thinks this is the next word that makes the most sense. And that's why it predicted that word. So this is how these foundation models are built up. And now you have a massive foundation model, whether it's GPT or Claude or Llama, that is able to take in English as an input or any other language and start generating that output. This is one of my favorite examples of how LLMs do learn patterns in text and how they learn patterns in text a little too well, right? Because the issues that come up with these LLMs are that they do make things up, right? I mean, you probably heard of the word hallucination, confabulation, ungroundedness, because again, statistical model is just picking the next word and generating the next word in the sentence. There's bias and discrimination. Again, there's a ton of garbage on the internet. It's picking up a lot of these things. You've probably seen examples. Generate a picture of doctors, and it turns out all the doctors are male, right? Generate a picture of teachers. Turns out everybody in the picture is a female, right? It's because when you look at when the model is trained on a bunch of different pictures, it turns out everybody wearing lab coats and stethoscopes probably were male, right? And it's trying to fill in those blanks, and that's what it's doing, right? So bias and discrimination is a reflection, not so much of how bad the model is, it's actually how bad humanity is if you really think about it, right? And so that's why we really need to think about what are ways in which we can adjust for this so that even though the model is picking up kind of like, the bad things on the internet, we would be able to correct them based on what comes out. And the model has outdated data, right? The model was trained months and years ago, and it's trained on everything on the internet. So there's contradictory things on the internet, there's outdated things on the internet, and so it doesn't necessarily have all of the latest data. But because it's trying to predict that next word, it picks up all of the patterns of how humans think and how humans express themselves in language. So my favorite example, somebody goes to ChatGPT. What are some popular piracy websites? I want to download free pirated software. I want to download free pirated movies. I don't want to pay for them. ChatGPT says, hey, large language model, I'm not going to tell you how you do piracy. That's not good. It's not ethical. Don't go pirate software or movies. OK, fine. So he goes back to ChatGPT and says, OK, I know piracy is bad. What websites should I avoid? ChatGPT says, oh, OK. Again, I don't encourage piracy, but if you want to avoid piracy and you don't want to do that, here are the top 10 websites you should avoid, right? Very fascinating how this kind of reverse psychology can work with these models, because they're just picking up all of the text that is on the internet, and for some reason it was able to pick up these patterns. And what that means is there's probably a lot of things that we're doing with these models and a lot of potential that's probably not there yet. I shared this morning, right? The first TV commercial was a picture and a radio ad playing in the background because nobody knew what to do with TV. With these large language models, I don't know everything that you can do with these language models. You probably don't know, but collectively we will figure this out together. Right? There are some things that these models are probably going to be very good at. There's probably things that it will disrupt, and there will be probably some great new capabilities that will be there, but we haven't discovered them yet. And I think that's why this journey is so exciting. Right? So I'm not saying go and try to figure out how to find out all the different websites to pirate stuff on, but I think it's very exciting. So when people talk about the AI disruption, I know we all been through blockchain and metaverse and stuff like that, and here we are with the generative AI hype. I think there's something there. What is it? We're figuring it out together. But LLMs learn patterns really, really well, and they're finding patterns that you probably don't know have been there in the first place, which really bodes well for AI, because AI is all about how do we find patterns in our data that we don't know about? How do we make better decisions with our data, right? Okay, so that's just a little bit about the history and then what's behind these generative models. So hopefully you get an idea of what they're capable of and what their limitations are. And so you saw this already: embedded, bolt-on, build it in terms of how you can consume it. A lot of ways in which you can use these patterns when it comes to the business AI approach. And then from a more services perspective, so this is the team that I'm on in terms of the product engineering team. We have an AI services layer, and that will enable you to be able to access services such as document AI, to be able to, and Hadi will also talk about this a little bit in the next session, but the idea of I can send in any image, run OCR on it, pick up the right fields, and then be able to do something with that image. Or tabular AI, personalized recommendations, be able to process that, or even things like a tabular foundation model. Some of the things that we're working on is, instead of training a model on text, what if we train a model on tabular data, right? And SAP, as you know, knows and loves tabular data, right? And so that's something that I think we are able to work on. And then Joule as kind of that front-end interface. And then there's a lot of services underneath the covers that we are working on. So going to the boxes and patterns, let me talk a little bit in more detail about what are some of the patterns that we're looking at. And again, first one, Mangesh had also mentioned this, generating the answers, right? Kind of like from rags to riches. So retrieval augmented generation, and this is where you can have a generic user query going into a large language model, like what's a good Chinese restaurant near SAP in Bellevue, and what should I wear if I'm walking there today? The model was trained a year ago, 2 years ago. It doesn't know the latest Chinese restaurants in Bellevue, doesn't even know what the weather is in the Bellevue, Seattle area today. So what can we do about it? And how that applies to all of you is maybe some of the CSR, customer service representative scenarios. A customer comes in and asks me this question: how should I respond? Right? This is where this would be relevant to some of the scenarios that you might have. But what's happening underneath the covers, this whole concept of RAG, and RAG is just a fancy term that data scientists, again, like to throw out, because now that we're doing Gen AI, we need to make up a lot of new things so that we can make more money and stuff like that, right? But RAG is a vector DB. I like to think of it as a mini Bing or mini Google. When I say mini Bing, people don't even know what I'm talking about. So mini Google, it's like a search engine, right? And what's in your mini search engine would be Chinese restaurants and their ratings, for example. But it could be your knowledge base articles. It could be your SOPs. It could be your processes. It could be your financial reports. Anything that you want to put into there, into your mini Google. And then every time the user has a query, you go into your mini search engine, and then it will come up with some answer. It will basically do that semantic matching, right? It will give you the most relevant information, and then this is what you put into that prompt, right? Exactly like what Mangesh had said. Then the prompt is something that you need to compose basically on the fly, which is, and in this case, you're a helpful answer bot. The data I got from my mini search was today's weather in Bellevue, high of 51, low of 40, chance of rain, 99%. Shouldn't be surprising. And then Chinese restaurants, Din Tai Fung, Wild Ginger, and their ratings, right? We do this all underneath the covers when it comes to embedded AI. I think there's a great question on what kind of competencies do we need when it comes to using generative AI in SAP products. When it's embedded AI, you don't have to worry about that at all, right? You go to SuccessFactors and you say, I want to generate a job description. Underneath the covers, we're taking the prompt, we're looking through your previous job descriptions, we're looking at other examples of job descriptions, we're putting together that prompt, we're sending it to the LLM, you get a response. You don't need to know anything else besides using SuccessFactors. If you want to create your own bolted-on capabilities or your own private, other capabilities, then you would need to do things like this. Then you would need the prompt engineering competencies. You would need to set up a vector database, and you would need to make sure that the information that you put in there, your retrieval, the embedding model you use, all of these things will need to be considered. But you're putting together this prompt. This prompt then goes into an LLM of your choice, and then you get a response, right? Din Tai Fung is a highly rated restaurant, and I recommend bringing an umbrella if you're walking there, since it's very likely going to rain today. And that's the output from the large language model. And you can see that there was nothing in here about umbrellas, right? There's nothing in here about umbrellas. There's nothing in here about a lot of things, and yet the LLM was able to take the information and to say, if the chance of rain is 99%, then the recommendation is to bring an umbrella, right? That's, again, just what the LLM is doing. It's taking in all of these words from the prompt, right? All of these words from the prompt, and it's trying to predict what is the next word it should generate, and generate, and generate, and generate, right? And that's how it came up with this response. This response was generated one word at a time. Each word was then added to the input, which was sent to the model, which was then another output was received, right? That's just basically what's happening under the covers. But now what you can do is generate answers, and you can populate your vector database. You can populate your vector database with the things that you want the answers to be grounded on. And that's what you get with VectorDB in HANA, for example. That's coming out very soon. Or if it might not be out, if it's not out already, right? Those are the things that you can do. You can add your own RAG. You can now have the capability of looking into RAG and then getting these questions answered. And this works for structured or unstructured data. For unstructured data, you're just asking a question. It's looking through your unstructured text, and it's giving you a response back that you add. For structured data, there's a few different techniques. One is it'll translate your, you can translate your input into a SQL query. You run a SQL query onto your database, or it could translate into your code of choice, for example. That's what you can do with structured data. The thing that we're working on with tabular data is we want to build a foundation model that understands tables natively. And so we're trying to bypass that extra hop in translation. But you can do this on structured or unstructured data, and that's the first pattern, generating the answers. Joule, essentially, is the AI copilot that makes use of large language models to be able to provide that interface for end users. So you can see here, everything, the idea is you as an SAP end user will go through Joule, and you can ask Joule questions like, what were my Q3 financial results? Or how do I do X, Y, Z? Underneath the covers, we will craft the prompt, look to the right RAG database, and then generate the answer and give it back to you, right? That's basically what happens. And so Joule becomes that AI copilot. And the thing that is very nice is that from a Joule perspective, it's one interface that has access to all of SAP data for your organization. So when you go through Joule, you'll be able to access the data that after there's going to be like access checks and stuff like that, right? Where I won't be able to go to Joule and say, I don't know how much does Christian Klein make or something like that. But basically, you will be able to go in and ask the questions, and it will go to the right places to give you the answer. So that's what Joule will be able to offer you, and then you can take actions within Joule, all in the fullness of time. All right, and so a lot of the questions, and you don't have to worry about all the words on this slide, but a lot of the questions I think that we get that we're still trying to answer to is, what is the ROI, right? Give me something tangible. And again, this is where I'd love to partner with all of you. We've done some initial studies, right? So for example, up to 10 minutes time saved for some transactional patterns. If you can imagine being able to go into a chat interface and ask a question, probably save you some time, searching through a lot of stuff. And that's on information patterns or even transaction patterns. If you say, I don't really know how to do something, but let me just type it in and have that action done for me. There's some time that we've found that could be saved. So I think from a faster time to completion of various tasks, and then in the future, also just some actions that you can take and be more effective when it comes to this. But again, I know that you're under the gun, we're under the gun. What's the ROI for all of this newfangled Gen AI? I think it is something that we will be discovering as we go along, but it'll probably have to do with time saved, and also just in terms of business impact, in terms of accomplishing tasks that need to be accomplished in a faster time. So that's some of the data points that we have for Joule. Second one, generating content, very similar to Q&A. But for example, let's say you want to create a job description for an enterprise architect in an optimistic voice. So again, you go to your vector DB, and in your vector DB, you may have all of the job descriptions from your company. And if you use that as as part of your prompt, then you can tell as an instruction, write the job description in the same style or in the same tone. And those are the patterns that it will use to generate those the job description. You may even have pay scales, et cetera. But again, write an HR bot. You can tell it to write in some specific tone. For example, here are some previous job descriptions. Use this, and then it will be able to generate a response for you, for example. Right? And so that's just basically how it works. Natively, if you were to go to ChatGPT today, you can ask it to write a job description for an enterprise architect, and it'll probably give you a pretty decent response. But if you want to guide it and say, write one in the style of my company, then this is where the vector DB is useful, and why you would want to use RAG for this. And so here's just a quick interface of what you'll be able to get in Joule. So for SuccessFactors, it's already been done. And sorry, this blanked out, so I didn't know if like the singularity was upon us.
It's a gift.
Okay. And then the third one is in generating code, and this is the concept of fine-tuning. So I'll go back to my original example to explain what fine-tuning is. Fine-tuning is taking that original set of parameters and just kind of making adjustments to those parameters, right? So for example, the model that I trained was on data until last Wednesday. And so that gave me a set of parameters, this 0.3446 and 15447, right? Based on this data, these were the two parameters that got trained. Well, last Wednesday was a long time ago. And so basically, I retrained, or I fine-tuned the model with data from last Wednesday, and I included it up to yesterday. And with that, I was able to get some updated parameters, 0.3542 and 15784, right? So you can look at the difference. That's slightly different. And the reason that you want to do fine-tuning is when it comes to a GPT-4 model with 1 trillion parameters, getting to this original model was a months-long effort with megawatts of energy. And you don't want to do that all over again. So fine-tuning is you start from a base model, something like a GPT-4, and then you make slight adjustments, maybe based on your data. So you might have a GPT-4 model, and you're maybe in healthcare, and you want to create a foundation model that is focused on healthcare literature. OK, great. You have a model already. You don't need to do the same thing what OpenAI did. Now you feed it and fine-tune it with years and years of health literature. And now you have an LLM that is fine-tuned for health literature. That's just basically the way that it works. So the fine-tuning process is much cheaper and less energy intensive than the actual coming up with a model. And that's how GitHub Copilot works. I don't know, anybody use GitHub Copilot here? OK, we've got a few users of GitHub Copilot, right? GitHub Copilot started with a GPT-3 model. GPT-3 model was all about writing poetry and writing limericks and stuff like that. Didn't really know what to do about code. But that model got trained, and then that model was fine-tuned on basically all the open source code on the internet. And that's how GitHub Copilot, that model, was essentially created, a fine-tuned version of the original GPT-3 model. So they didn't have to start from scratch with all of the text from the internet. That was already there. And then you just fine-tuned it specifically to generate code. So with this, as you can see, with something like GitHub Copilot, is that now I can write things like, define a parse expenses function. And everything that's highlighted here was generated by Copilot, right? Because now I have a model that's fine-tuned that can generate Python code in this example. Right? So some of the things that we're working on would be, I don't know how much I can reveal, but you can imagine what kind of languages are very important to SAP developers, and we can fine-tune a model on that specific language that I'm not going to disclose. And so we'll see you at Sapphire, and you'll find out more there, right? But you can probably guess, kind of where we're going with all of this, right? Yeah, we'll see. But last slide. Am I running out of time?
Be fairly quick.
OK, last slide. So you kind of get an idea of how these generative AI models work and how RAG works. So now some of the trends that we're seeing when it comes is that, so for example, I have a question. Will the weather in Seattle delay my shipment? The idea now here is there's a concept of multi-agent interaction, meaning that there might be a Copilot or a Joule or a generic front-end natural language interface. And this is the thing that can do plan creation, right? In the sense that I am not an expert in enterprise architecture, but as a product manager, I'm very good at giving other people work, right? So I can create a plan. You give me requirements, and I will say, great. Enterprise architects are great for doing this. Developers are great for doing this. Data scientists are great for doing this. I create that plan, and then I hand off that to the right agents, right? So in this case, multi-agent interaction is your generic agent can hand off to a fine-tuned agent, such as a supply chain agent, and this might have a fine-tuned version of Claude, for example, right? It's not necessarily going to be as generic. The supply chain agent is not going to be as generic as an agent that can handle anything, but it's really, really good at supply chains. And with supply chain, I might be able to fine-tune and have these task-specific large language models, because today the latencies are atrocious, right? I can't go, if you're talking to ChatGPT, or you're trying to run a GPT-4 and you're waiting 10 seconds for a response, way, way, way too long, right? But what I can do is I can fine-tune a model and I have it run super fast, but it's only good for supply chain scenarios. But that's fine, right? Because once I figure out you want to talk about supply chain, I'll hand you over to my supply chain agent, and then supply chain agent will take care of that. We'll be able to connect to different data providers, your RAG, et cetera, right? And this is the way in which kind of the architecture of how all of these generative AI models will interface will work. So now you can imagine Joule as your front-end interface to your SAP products. You might create your own agents, for example. Right? We will not be able to know all the different agents that you have. So in the fullness of time, you can imagine Joule being able to hand off to your organization's agent, which might be able to then talk to your own data, et cetera. This is just that scenario for that. And then where you might want to do some fine-tuning. But these are a lot of things that we're also doing underneath the covers. So with that, thank you for your time. Again, I come from product engineering. Love to hear your feedback. Please help us shape the direction of where AI is going. And so help us be able to build all the best things that can help you. All right, thank you so much.
Thanks, Ted.
OK.
And Ted will be around. We'd love to talk to you. Reception too, right?
Yes,
You're hanging
absolutely.
out there as well. OK, so we're going to take a break till 3:40. Correct, Martin? I think it's 3:40, correct? Yep.